chemical kinetics. Chemical kinetics. Question answer discussion. First question, define average rate and instantaneous rate. Average rate is change in the concentration of any of the reactant or any of the product by change in the time. By changing the time. Once again, so the average rate is change in the concentration of any of the reactant or any of the product by changing the time. இப்படி சொல்லலாம் definition. Change in the concentration of any of the reactant or any of the product per unit time under specified time interval. Under specified interval of time. Okay. Next, instantaneous rate. Instantaneous rate is rate of the reaction at a particular instant of time. Instantaneous rate. Instantaneous rate is defined as rate of the reaction at the particular instant of time. Okay. Next, second question. Define rate law, rate constant. What is rate law? Rate law is expression which equate the rate of the reaction to the product of the rate constant and the concentration of reactants rise to certain exponential power. So rate law expression or equation which equate rate of the reaction to the product of the rate constant and the concentration of the reactants to the certain exponential power. Okay. The next step. What is rate constant? Rate constant defined as the rate of reaction. Rate constant defined as rate of reaction when the concentration of the reactants maintain unity. Concentration ஒன்றாக இருக்கும்போது அப்போதான் rate of reaction rate of reaction is equal to rate constant. So rate constant defined as the rate of reaction when the concentration of the reactants maintain unity. Third question. Derive integrated rate law for a zero order reaction. Zero order reaction in which rate of the reaction is independent of the concentration over a wide range of the concentration is called zero order reaction. Zero order rate of the reaction is independent of the concentration of reactant over a wide range of the concentration. So consider reaction. A gives product. Okay. Here rate law is rate equal to, that is minus dA by dt. Rate equal to rate constant into concentration of reactant A power 0 for 0 order. So minus dA by dt equal to K into 1. A power of 0 is 1. Interchanging minus dA equal to KTT. Integrate this equation between limit A0 at 0 time, A at time t. Integrate பண்ணுறோம். என்ன பண்ணுறோம்னா A0 को A को limits. இங்க dt time 0 time to time t. Okay. இப்போ integrate பண்ணினா minus dx integrate பண்ணா x வரும். So minus dA minus a. Okay. So substitute limit a நாட்டும் a போடணும். இங்க k t limit 0 to t. Substitute limit. So minus a minus of correct minus a naught. So first limit a போடுங்க minus a naught. Okay, equal to kt. So plus and minus minus up to a naught minus a equal to kt, or k equal to a naught minus a by t. That வந்து 0 order உடைய rate constant expression. Okay. Next question. Question number 4. என்ன போடுறதா? Question number 4. Define half-life of the reaction. Show that for a first order reaction, half-life is independent of the initial concentration. Half-life of the reaction. Half-life of the reaction defined as the time required for the reactant concentration to reduce one half of its initial value. Half-life is defined as the time required for the reactant concentration. Time required for the reactant concentration to reduce or to reach one half of its initial value. தொடக்க கான்சன்ட்ரேஷன்ல இருந்து பாதி கான்சன்ட்ரேஷனா மாறதுக்கு தேவையான டைம். ஃபார் ஃபர்ஸ்ட் ஆர்டர் ரியாக்ஷன் k equal to 2.303 by t log a naught by a. Okay, when time t equal to t of a equal to a naught by 2. Substitute here. Okay, equal to 2.303 by t of log of a naught by 2. A naught will cancel. 2 value போடுமா? Okay, equal to 2.303 by t of logarithm of 2. Log 2 value okay. K equal to 2.303 by t of log 2 value 0.3010. So k equal to 0.6932 by t of equal to 0.6932 by k. So in the question is next, fifth one. What is an elementary reaction? Give the difference between order and molecularity. Okay. What is an elementary reaction? Fifth one. அஞ்சாவது விஷயம். அதாவது elementary reaction each and every single step in the reaction mechanism. என்ன சொல்லுங்க? Each and every single step in the reaction mechanism is called elementary reaction. அதாவது ஒரு ரியாக்ஷன் பார்த்தீங்கன்னா நிறைய ஸ்டெப் நடக்கும். ஓகே, அப்போ ஈச் அண்ட் எவ்ரி ஸ்டெப், ஒவ்வொரு ஸ்டெப்பும் இந்த ரியாக்ஷன் மெக்கானிசத்தில் இருக்கிற ஒவ்வொரு ஸ்டெப்பும் தான் எலமெண்ட்ரி ரியாக்ஷன். டிஃபரன்ஸ் பிட்வீன் ஆர்டருக்கும் மாலிகுலாரிட்டி வெரி இம்பார்ட்டன்ட் கொஸ்டின் இது. ஆர்டர்னா சம் ஆஃப் த பவர்ஸ் ஆஃப் த concentration terms involved in the experimentally determined rate law. Sum of the powers of the concentration term involved in the experimentally determined rate law. Experimental rate law concentration powers கூடுதல். Molecularity means total number of reactant species, எவ்வளவு reactant species that are involved in the elementary step. Total number of the reactant species that are involved in the elementary step. Second, order எப்படி இருக்கலாம்னா it may be fractional ஆகலாம், 0 or integer. It is always whole number, molecular. Third, it is assigned for overall reaction. Or if we assign for overall reaction, it is assigned for each elementary step in the reaction mechanism. It is assigned for each elementary step up to now. Sixth question. Explain the rate determining step with the example. Sixth question. Explain rate determining step. Rate determining step means slowest elementary step. Rate determining step na slowest elementary step in the reaction mechanism is called rate determining step. Slowest elementary step. Slowest elementary step. Slowest elementary step in the reaction mechanism is called a rate determining step. For example, in the hydrolysis of tertiary butyl bromide, first step tertiary butyl bromide, first step form a carbocation. Tertiary butyl carbonium ion in formula. This is slowest step, rate determining step. Okay. In second step, nucleophile. Second step nucleophile attack from OH minus attack from second step gives tertiary butyl alcohol. So first step is the formation of a tertiary butyl carbonium ion. This is the slowest step, the rate determining step. Okay. So describe the graphical representation of first order reaction. Describe graphical representation of first order reaction. Graphical representation. Representation of first order. So first order reaction ln A naught minus ln A equal to K. First order. Suppose ln A equal to ln A naught minus K. So this equation is in the form y equal to mx plus c. Okay. If you plot ln A around y against x not time, plot karna, we get a straight line with negative slope. Slope is equal to minus k and the y intercept. The intercept is ln A naught. You know, graphical representation. Okay. Next regarding here, ninth one. What explain the effect of the catalyst on the reaction rate? Once again, explain the effect of the catalyst on the reaction rate. First, catalyst. Okay. Effect of the catalyst. Ninth one. Catalyst affect the rate of the reaction. Catalyst is a substance which alters the rate of the reaction without itself undergoing any change in the reaction. Catalyst என்ன பண்ணுனா ரேட்டை மட்டும் அதிகமாக்கும், ஆனா அது என்ன பண்ணாரு does not participate in the reaction. Once again, catalyst is a substance which alters the rate of the reaction without undergoing itself in the chemical change. Okay, they will be participate in the reaction, but they again regenerated at the end of the reaction. They will be regenerated, participate or in the presence of the catalyst, activation energy is lower. So, சாதாரணமாக activation அதிகமாகும். In the presence of the catalyst, activation energy is lower. A more number of the molecule cross the energy barrier. and change over to the product. So the rate of the reaction increase, activation energy decrease, rate is increase. Example, in the oxidation of oxalate ion by MnO4, in the oxidation there, MnSO4, manganese sulfate, act as a catalyst. In the presence of manganese sulfate, the rate is increased. Okay, that's all. Next is question number 13. Explain collision theory. Collision theory. Explain briefly the collision theory of bimolecular reaction. So, collision theory is according to this theory, chemical reaction occurs as a result of collision between the reactant molecule. According to collision theory, reaction occurs as a result of collision between the reactant molecule. Reactant molecule ஒன்றோடு ஒன்று மோதுவதால் reaction ஆகும். So A2 gives gas, B2 gives 2AB. Okay, a product. Okay, product. According to this theory, rate of the reaction is directly proportional to collision rate. According to this theory, rate of the reaction directly proportional to the collision rate. Collision rate means number of molecules colliding per liter per second. Number of molecules colliding per liter per second. அப்போ rate directly proportional collision rate. Okay. So collision rate is directly proportional to concentration of A to B2. Collision rate or collision rate equal to Z into A2 into B2. First step, the rate of the reaction directly proportional to collision rate. Collision rate means number of the molecules colliding per liter per second. Collision rate directly proportional to the reactant concentration equal to Z. That is the proportionality constant. Next, all collisions are not effective to lead to the reaction. எல்லா collisionும் ப்ராடக்டை கொடுப்பதில்ல. In order to react, colliding molecule possess certain amount of minimum energy called activation energy. அதாவது react ஆகணும்னா colliding molecule possess certain amount of minimum energy called energy of activation. Energy of activation. Yeah. In the activation energy உள்ள இருந்ததுன்னா energy no reaction occur. No reaction occur if the molecule collide with the energy less than the energy of activation. Activation energy. So fraction of the effective collision, அதாவது எந்த molecules activation energy பெற்றிருக்கிறதோ அது fraction of the effective collision given by the formula e to the power of minus Ea by RT. It is a fraction of the effective collision. Because even if the reactant molecule collide with specified energy, sufficient energy, around sufficient energy ஓட அது மோதினா கூட they would not give the product unless they have a proper orientation. அதாவது reactant molecule sufficient energy ஓட மோதினா கூட ப்ராடக்ட் கொடுக்கும்னு சொல்ல முடியாது unless they have a proper orientation. Okay. So fraction of the effective collision, fraction of the effective collision with the proper orientation. Fraction of the effective collision proper orientation ஓட இருக்கிற fraction of the effective collision is given by the steric factor P. Steric factor P ங்கிற steric factor நம்ம represent பண்றோம். Okay. So rate is equal to steric factor into fraction of effective collision and collision rate Z into A2 into B2. Okay. So rate of reaction equal to steric factor into fraction of the effective collision into collision rate. We know according to the rate law, rate of the reaction equal to rate constant into concentration of the reactant A2 and B2. So by equating, we get K equal to P into F into Z, P into F into Z. We know F is what? E to the power of minus dA by RT. Okay. That's R Z P e to the power of minus dA by RT. Yeah. Okay. Compare pannanga we get this answer. Next, wait a minute, 1 minute. Okay. Next question. 14. Write Arrhenius equation and explain the terms involved. Arrhenius equation. Question number 14. Arrhenius equation in the form of 3 matter. Arrhenius equation K equal to A e power of minus EA by RT. So K is a rate constant, A frequency factor, E is activation energy or gas constant, T temperature. Okay, review. K rate constant, A frequency factor, E activation energy or gas constant, T temperature. Next question, 71. Explain pseudo order reaction with example. Pseudo order, something. What is pseudo order reaction? A second order reaction can be altered into first order reaction by taking one of the reactant concentration excess. That second order reaction first order by taking one of the reactant concentration excess. One concentration pseudo first order reaction. Second order reaction can be altered into first order reaction by taking any one of the reactant concentration excess. Example, in the hydrolysis of methyl acetate in the presence of acid is example for pseudo first order. They get acetic acid and methanol. Okay, the rate of the reaction equal to rate constant into ester concentration, methyl acetate concentration and water. Since water is taken large, the concentration of water is almost constant. So, this concentration of water is, there is no change in the appreciable change in the concentration. So, concentration of water is almost constant. So, by merging K and H2O, we introduce a new constant K dash. K dash into CH3, COO, CH3. Okay, this is an important question. Pseudo first order. Next question. Question number 21. How do concentration of the reactant influence the rate of the reaction? Concentration எப்படி rate பாதிக்குது? Question number 21. Effect of the concentration. So, rate of the reaction increases with the increase in the concentration of the reactant. அதாவது reactant concentration அதிகமாக்கினா ரேட்டும் அதிகமாகும். According to the rate, according to this, this is explained on the basis of collision theory. Once again, the rate of the reaction increases when the concentration of the reactant increases. This is explained on the basis of the collision theory. According to the collision theory, rate of the reaction depends upon the number of the collision between the reacting molecule. அதாவது ரேட் எதை பொறுத்தது, எவ்வளவு தடவை மோதுதோ நம்பர் ஆஃப் த கொலிஷனை பொறுத்தது between the reacting molecule. When the concentration increase, greater the possibility of the collision between the reacting molecule. Concentration அதிகமாக இருக்குன்னா நிறைய மோதல் நிகழ வாய்ப்பு இருக்குது. Greater the possibility of the collision between the reacting molecule, so rate of the reaction increase. Okay. Next question. Question number 22. How do nature of the reactant influence rate of the reaction? Nature. Question number 22. How do nature? Wait. Okay. Question number 22. Nature of the reactant. Okay. So, we know chemical reaction involved between the we know chemical reaction involves breaking of existing bond and formation of new bond. Okay. அதாவது chemical reaction எப்படி நடக்கும், ஏற்கனவே இருக்கிற பாண்ட் உடையும் formation of a new bond leads to the product. The net energy involved in the product depends upon the nature of the reactant. The net energy involved in the process involved net energy depends upon the nature of the reactant. So, hence, rate of the reaction depends upon the nature of the reactant. Once again, chemical reaction involves breaking of existing bond and formation of new bond. Okay, the net energy involved in the process depends upon the nature of the reactant. So, the rate of the reaction depends upon the nature of the reaction. Okay, let us consider redox reaction between FAS and KM. Let us consider two reactions. One FAS and KM consider panna, இன்னொன்று oxalic acid and KM. இப்போ ரெண்டு ரியாக்ஷன் கன்சிடர் பண்ணலாம். ஆக்சிடேஷன் ஆஃப் ஆக்சலேட் அயான் பை KMnO4 இஸ் வெரி ஸ்லோ. இந்த ரியாக்ஷன் ரொம்ப ஸ்லோவாக நடக்கும் கம்பேர்ட் டு தி FAS KMnO4. ஓகே, here heating is required for this reaction. இதுக்கு heating தேவை. 60 degree temperature, 60 degree centigrade temperature is required for this reaction. So this reaction is very slow compared to FAS and KMnO4. So the rate of the reaction depends upon the nature. Here two questions again, extra question. Difference between rate of the reaction and rate constant. Rate to rate constant go. Rate is it represents the speed of the reactants that are converted into products at any instant. Speed of the reactant converted into product at any instant. It is a proportionality constant. Second point, it is measured as a decrease in the concentration of reactant or increase in the concentration of product per unit time. இது எப்படி மெஷர் பண்றோம்? Decrease in the concentration of reactant or increase in the concentration of product per unit time. இது equal to the rate of the reaction. Rate constant equal to rate of the reaction when the concentration of reactants unity. Concentration unity இருக்கும்போது rate of the reaction is equal to rate constant. Third, it depends upon the initial concentration of the reactant. Reactant initial concentration பொறுத்து. Initial concentration அதிகமாக இருக்குன்னா rate fast ஆகும். சரியா? இது does not depend on the initial concentration. Last question, derive the important question, rate of the reaction, rate law for the first order reaction. First order reaction. First order for first order reaction in which rate of the reaction depends upon the only one concentration. ஒரே ஒரு கான்சன்ட்ரேஷனை பொறுத்தது. Depends upon the reactant concentration power 1 அப்படின்னு சொல்லுவோம். So A gives product. First order. So rate law minus dA by dt equal to K into A to the power 1. Okay. இங்க என்ன வரும்? Minus dA by dt equal to K into A தானே வரும்? A to the power 1. Okay. Next interchange minus dA by A கொண்டு வந்தா equal to K dt. Integrate between the limits. Integrate பண்ணுங்க between the limits. A naught at time 0, A at time t. Integrate பண்ணுங்க K dt time 0 to t. Okay. இப்போ integral of dx by x equal to ln x. Okay. இங்க என்ன வரும்னா minus ln A ன்னு வரும். Substitute பண்ணுங்க A naught. Okay. Equal to K dt க்கு t வரும். Limit 0 to t. Substitute பண்ணலாம். Minus ln A minus of minus ln A naught equal to K t minus 0. Okay. Plus ஆகுமா? அப்போ ln A naught minus ln A equal to K t. Okay. இப்போ ln A naught by A இப்படியே இருக்கும் இல்லையா? Equal to K t. Ln வந்து ln m minus ln n equal to m by n. அப்போ K equal to 1 by t ln A naught by A. On last stage K equal to 2.303 by t logarithm. இது வந்து log base தான் மாற்றணும். Exponential ஆகும். A naught by A. Okay. Thank you.